Uh, right now I'm going to give you an additional example of how to sketch the graph of piecewise functions. This one's a little more involved and it throws in a square root function. Square root, remember, is the inverse of an x squared function. So basically it's going to tilt an x squared sideways. Now a basic square root function, parent function, y equals square root of x, looks something like this. It needs to be a function, so it starts at 0, 0, and ends up being only the top half of a sideways parabola. So with that in mind, when I graph this one, although it's going to be a variation because of the x minus 4, it's still going to have that same basic shape. So that kind of gives me a clue as to what I want to do. Now, when I graph the g of x equals square root of x minus 4, and we're going from 4 on x greater than 4, I'm going to consider that the domain of this function is greater than or equal to 4 because of the x minus 4 underneath the radical. So a little bit of review over the domain algebraically. When I set up a table, we're going to call this G1 and this G2. For G1 of x, I'm going to have my x value and my y value. So I'm going to start at 4. Now, knowing it's x strictly greater than 4, I'm going to do an open circle there. But if I take the square root of 4 minus 4, I'll do this for this one, I get the square root of 0, which is 0. So there's my first order pair. Okay, so over 4 up 0, 1, 2, 3, 4 up 0 would be here. I'm going to put an open circle at that point because it's strictly greater than 4. Now I'm going to find numbers that have nice square roots. When I fill in x is 5, I get the square root of 1, which is 1. So I'm going to go over 5 up 1. I really have enough, knowing what this graph looks like overall, I really have enough to start graphing this. This is a square root function shifted to the right 4. But I like to go ahead and fill in another order pair. I know if I take the square root of 4, I get 2. I'll get a nice neat value. And the x value that'll make that would be 8. So to give you an example here, that'd be the square root of 8 minus 4, which is the square root of 4. Or 2. I'm going to look at nice neat values if I can, so I kind of think about what x values are going to give me a better y value back out. So over 8 up 2, I have something like that, and there is that function from there on. Now G2 of x is this line. Okay, so I have G2 of x, and so I have an x value and a corresponding y value. And since it's 1/2 x plus 5, I'm going to pick numbers less than or equal to 4 that are going to be even, so when I take half of them, it gives me a nice neat value back out. Now I'm going to make sure I catch 4 in there, so I'm going to start with 4. Okay, I'd have 1/2 of 4, which is 2, plus 5 is 7. So over 4 up 7, it's less than or equal to 4. So when I go over 4 up 7, I'm going to put a closed circle, 1, 2, 3, 4, 5, 6, 7, right in there. Okay, now I know this is a line with a positive slope, so I can really drop down left 2, drop 1, down left 2, etc. Okay, to get another order pair. Drop down left 2. Okay, that's the y-intercept, y equal 1/2 x plus 5. So if I fill in 0, I'll get 5 back out. I could fill in, like, say, -4. 1/2 of -4 is -2. -2 plus 5 is 3. So at -4, I get 1, 2, 3. That looks reasonable in line. I'm going strictly less than or equal to 4, so I'm strictly going to the left with this line towards negative infinity, like so. And that is the graph, ladies and gentlemen, that satisfies the conditions for g of x, this piecewise function.